Hello everyone, my name is Ankush and in this video we are going to learn about self-signed certificates. Before diving deep into self-signed certificates, let's understand some general concept. First, we will learn how can we create an SSL certificate. Next, we will learn how SSL certificate works, how client and server communication happens. Then we will look at a high-level design. So just click here and understand how can we create an SSL certificate. To create an SSL certificate, the first step is to generate a RSA key pair. To generate an RSA key pair, you can use OpenSSL, which is an open source tool and very famous for doing the task related to certificates. So you can use OpenSSL tool to generate a public private key pair, and those public private keys will be generated in a single file which will have a .key extension. The extension could vary, but normally it is recommended to use .key that represents a key. Now you have generated a RSA key pair or public private keys. Next step, you will create a certificate signing request. A certificate signing request is a request that is created before it is sent to a certificate authority for signing. So we will be using we will be using public key and some metadata like country, state, email, common name, those things, and we will be creating a certificate signing request. So this certificate, you can see here we have created a CSR, and we can also call it unsigned certificate that basically includes public key and metadata. Now this CSR is ready. The next step, we are going to send this CSR to a certificate authority, just like DigiCert, Global Sign, VeriSign. These certificate authority uses private key of their own certificate and create a signature of this CSR. So now you can see we have received a signed server certificate which includes three things: public key and metadata that was already present earlier. Now apart from that, it also includes the signature. So all these three things makes this a complete server certificate that we can install on our web server to serve a website. Next, we will understand how SSL works. So let me click here. So you can see, you now assume that I am running this website here and I have created this SSL certificate from the previous step. This certificate includes public key, metadata and signature, and private key is already with us. We have not shared it to the certificate authority. So all those things are present on our web server and we are running a website. Now if if some client hit xyz.com with HTTPS, what happens? This server will send out this SSL certificate to the client. Client will download this certificate and it will try to find a root certificate that belongs to this certificate. Remember, in previous step, we have created, we have signed this certificate with the certificate authority's private key, but the public key is present on your computer. So this is trusted root certificates. So if you see on my computer, I have lot of certificates which are pre-installed, and even on your mobile phone or on your local computer, these certificates comes when you purchase a computer or a mobile phone. So these certificates includes the public key of the certificate authority, but the private key are kept on the on those I are kept with these certificate authorities and are used to sign the certificate. So now we have received or we have downloaded the certificate on our website. It will The client will try to get the relevant certificate uh, and will try to retrieve its public key from here and will validate the certificate signature. So once the signature is verified, what will happen? This client, for example, if I am running this website, my computer is client. So my computer will generate a random number and will encrypt that random number with this public key, which it has retrieved from the certificate because it has downloaded the certificate. So it has, this client has the public key of your SSL certificate. So it will generate a random number and will encrypt that random number with your public key, and it will send that encrypted text to the website. Now this website has already private key, so it is able to decrypt the random number, sorry, the text, and retrieve the random number. Now if the decryption is successful, then it will send an acknowledgement to client that's, that SSL handshake has been completed, and now they can communicate with symmetric encryption using that random number. And if encryption fails, or sorry, if decryption fails, then connection is dropped right away, and this SSL connection can is no longer kept. So this is how an SSL certificate or client server flow works when we are using SSL certificate. On a high level design, if we see, so this is our certificate authority. So consider this certificate authority from where you are going to sign your certificate. It could be global, what was the name? Let me check. I am not remembering. DigiCert, Microsoft Root Authority, GoDaddy, Global Sign. So it could be any certificate authority. And this certificate authority also owns their own root certificate, which has their own private and public key. Private key are kept with them, and public key are used in root certificates which are installed on your system. So now if you go there, you ask them to sign your certificate, then they use their own private key and sign your certificate. So this is how a overall picture of SSL certificate looks like. Now now let's understand, or let's talk about self-signed certificate. So why do we need a self-signed certificate? Self-signed certificates are needed when we are doing the development, and we want to run our website on HTTPS, and we want that our website should run on HTTPS, or maybe if we have developed some API that is running on HTTPS and we want to access it from our mobile phone just for the development purpose. So we don't want to buy a new SSL certificate and get it signed with some certificate authority. So we prefer to create our own certificate authority. So if you see in this diagram, these are the certificate authorities: DigiCert, Global Sign, VeriSign. These are those certificate authorities which there we went to sign our certificate. So why don't we create a local certificate authority? So what will happen? Okay, let me go back here. So if you generate a certificate and you, instead of get it signed with the CA, you can create your own root certificate. Your own root certificate will have your own private key and public key, and you will use your own certificate authority's private key to sign the certificate, because this certificate is now signed by your own root certificate authority. So that certificate authority's public key or its root certificate should also be present on your computer here. Otherwise, it will not be able to trust it. So if you create a root certificate and install it here, and then create further certificates and sign them with your own private key, so your computer will be able to trust those certificates. And now you can, if you have created a root certificate, then you can also install it on your mobile phone. And when you try to access a web API through your mobile app, or you try to access a website that is signed with your local certificate, so that will work on your mobile phone, because your mobile phone can trust it because it has the certificate authority installed. I mean the root certificate of the certificate authority installed on your mobile device. So this is how this entire flow works. I know this is little complex, but if you give it some time, then and uh, go through this entire picture, then you will have a better understanding. Now time to do some practical or hands-on. So we are going to create a root certificate, and uh, I mean we are going to create our own certificate authority. And to create an own certificate authority, we have to create a root certificate. So once we have created a root certificate and established a certificate authority of our own, then we will use the private key of our certificate, of our root certificate, to uh, create further certificates. So those certificates, we will call them as a self-signed, because we are signing them with our own root certificate's private key. Okay, so let's do some hands-on, and then things will get more clear to you. So in the first step, we are going to create a root certificate or certificate authority. So I will open this folder, and I am opening command line. Okay, so here first we will define the certificate authority name. So I'm using Windows, but I have uh, pasted the commands for Linux as well. So I'm using Windows, so I'm just creating a variable and setting it to some value. So I have created a CA name, certificate authority name, and the value is my or root CA. Now I'm going to create a private CA for this certificate authority. So I'm using this command. So what will this command do? It will generate a private key. As I said, the first step to create a certificate is to generate a key file, public private key, and it will generate a .key file. So coming back, I will copy this. I will hit enter. So it is generating RSA private key. I'm entering 123 123 as my passphrase. Again 123 123. So you can see a key file has been generated, and if I open this key file, so this key file looks like this. And this, however, they are calling it private key, but this private key includes both public key and private key, because private key is also contained in this file, so that's why they are calling it private. But yeah, you can extract the public key from that key file, because that is basically RSA key pair, and I in key points I have mentioned it. So you can use this command to print the hidden public key, or if you want to export that public key, then you can use this command. So when you generate a key file, you eventually generate a public private key pair. Okay, now we have generated a private key. So now as of now we are creating a root certificate. So we have generated a private key and public key. Now let's create a root certificate. So we will be running this command. So you might be thinking, like, I have tell you the procedure of creating a certificate. So create a key file, then we create a CSR, and then we get it signed with some certificate authority. But root certificates are always self-signed. So we don't need a certificate authority, because we are creating a certificate authority. So here we have created a public and private key pair, and here we are going to create this certificate, and this certificate will be signed with their own private key. That's why we call the root certificates are self-signed certificate. And if you look into the command as well, you will find that in the key part, I am passing the CA name dot key, which will refer to this key, which I have just created. So it will create a self-signed certificate or self-signed root certificate. Now let me hit again. I have to enter passphrase. It is asking me few information, like which I am calling as metadata. So I have provided all the information, and I can see that this certificate, or which is our root certificate, has been generated. So now we have we have created a root certificate. Now we need to install this root certificate here. Okay, so what we will do, add in the fourth step, I have written add certificate authority to trusted root certificate. And for Windows, just double click on this file. So all you need to do is just double click here. It will open this window. Click on install certificate, select a local machine or current user, whatever you need. Then next, it will ask you for a pop-up, and then you just need to click place all certificates in the following store. Select browse, click select trusted root certification authorities, and click next. And just to finish, import was successful. Close this, come here and refresh this. So the certificate now should present here. So you can see my work, this certificate is now present here, and it is in root trusted root. So you have created your own certificate authority. However, we have not named it like a certificate authority, but yeah, uh, we have created a root certificate, and that is something equivalent to creating your own certificate authority. The next step, creating a SSL certificate signed using root certificate's private key. So now we have created this certificate. So now the next step, we are going to create a certificate that would be signed with this certificate authority. So now I am declaring another variable. So I will close all this. I have declared set my cert and my server. So I'm creating this certificate for my server. And now I will use this command. So what this command will do, create an SSL certificate. This command will create a new RSA key pair. Okay, so now this is the step uh, that I was telling you. So this is my second step, and if I go ahead, so I have just created this. I have just I'm just creating a CSR. So if you see, okay, let me see what command I have. Sorry. Uh, so I just use this command. So this command is basically uh, create both. I'm okay. So now this command will create both key and new key. So as you can see here, I have used new key. So it will generate a new key pair, and it will also create a CSR, which is server signing request. So both step 1 and step 2 are covered in this same command. Okay, so it is asking me for my country again, IN. So this is the metadata information I am providing here. Okay, my org IT, my org question 354. Okay, a challenge password. So I'm keeping it 123123 for now. An optional company name, my org. Okay, so here you can see a CSR and a key is generated. So this key is basically our public private key, and this CSR is something which is a unsigned certificate that we need to certificate signing request. So we need to get it signed with the private key of our root CA, which is this. Okay, so in the third step, we are going to create a send subject alternative name. So this is something, for example, we are creating a certificate for our website abcd.com. So we have to provide those domain name, or if we are running it on localhost, or then we have to provide that name localhost, because that name is included in the certificate. So, and when certificate is downloaded by the browser, it will check for that name, whether that is present. It will try to match the host name with the with with this name which is present in the certificate, to make sure that this certificate is being used with the expected domain. So we are going to generate the send file, and to create a send file, so on the Windows I will run this command. Okay, so I will run this, and this will open a notepad file here, and I will put this part, copy this and paste it. Because I want to run it on my local host, so I will use localhost, and I will remove rest of the things, and I will save it. Sign the CSR using private key. So now what we are going to do, we are going to sign this CSR for our server with the private key of my org root CA, and we are going to refer all these ext, I mean the send file also in the command. So I will copy this command, so you can see I'm using ext, the send file that we created, and we are output file would be the CRT file, and the key would be CA key, certificate authority private key, and the CSR is here. So I'm just running this command to generate an SSL certificate. Oh, sorry. Oh, again, what happened? Let me try to copy it again. Copy again. Password 123123, and it should generate a new pass certificate. Okay, so certificate has been generated in my server. So now we are going for the demo. So let me revise this. So what we are going to do, we are going to create a website that will be, using this server certificate. So this certificate is basically the certificate which is present here, my server, and my website is going to use this certificate. And once my client runs my website, which is also me in the same case because I'm running everything on my PC, so my browser will download this certificate, and is because my browser is acting as a client, and it will try to validate the signature which is present in this certificate with the public key of the root CA. So that is also present on my computer. So if everything everything is fine, then this certificate will be working fine, and you won't be getting any error, and everything will be running over HTTPS. But again, I mean, however, this is my machine. I have the server, I have the client on my local host. But you can also create a scenario like you have created a website running on your local host, and now you can install the root certificate, this certificate, on your mobile phone, and try to use ipconfig to config to get the IP of your local machine, and then try to run the access the website. And I think you should be able to access your website with HTTPS from your mobile phone as well. Okay, so now I'm creating a ASP.NET Core application, and in order to use that certificate, I'm going to again step 3, I guess. Yeah. So create an ASP.NET Core application. I just created that application, and I will have to generate a PFX file because that is required in when we are working with on Windows. So I have a PFX file is nothing, just that includes both the public and private key. So both the certificate and key, I will key includes private key and certificate includes the certificate. So it will combine both the files using this. So I will run this command. Sorry, let me close this command window. Okay, let me clear also this one. Okay, so let me just hit enter, and password 123123, verifying 123123. Okay, so now it has generated the PFX file. You can see uh, where it is. I cannot figure it out. Is it? Yeah, it is the PFX file. So now what we are going to do is just use this file. Okay, so let me go back and come back. So I will copy the path of this pfx file. Okay, and then we will go to the next step, and then we'll copy this particular section and we'll add it here. So we'll add it here, and here I will provide the path of our pfx file. So this server is going to, I mean, my this application is going to use this self-signed certificate, and 123 is the password. So you can also install this server uh, on your local system in the personal certificate, but I mean, for this demo I am accessing this certificate from its path. Okay, so I have made these changes. So let's run this application, and when we run this application, uh, okay, so we can see this using HTTPS because we are getting this log icon, and if we click here, the connection is secure, certificate is valid, and if we go here, we can see that my org, so everything is fine, and we can say that this website is using this certificate authority which we had created my org, because we can verify it from this name. And in the detail, if we go uh, in the extensions, subject alternative name is coming as localhost. So yeah, I mean, we have created we have created our own root certificate or certificate authority, and then we created a self-signed certificate, or we can say a certificate that is signed with our local authority, and we can use that in our website. So this is how you can use the locally generated or the self-signed certificate in your website. I hope you have liked this video. Thank you very much for watching.